All right, guys, let's see this top one. Vertical asymptotes, horizontal asymptotes, and holes. Let's get the horizontal asymptotes out of the way first, because that's usually a little bit easier. So we take the limit as x goes to infinity, okay, of that top one, and we say, okay, well, the largest degree is 3, so I can divide everything by x cubed. Okay, so I have 3x squared divided by x cubed plus 9x over x cubed minus 30 over x cubed. Okay, then I have x cubed over x cubed plus 4x squared over x cubed minus 25x over x cubed minus 100 over x cubed. And then let's simplify that. So we take the limit as x goes to infinity. Okay, let's see, what am I going to get here? This will be 3. Oh, I'm sorry, that'll be 3 over x. My fault. Okay, that's going to be 3 over x. Okay, this will be 9 over x squared. This will be, can't do anything with that, minus 30 over x cubed. Okay, down here, x cubed over x cubed is 1. This will be 4 over x. This will be 25 over x squared, and I can't do anything with that last one, 100 over x cubed. Okay, so let's see. Okay, so as x goes to infinity, everything in the numerator goes to 0. And down below, as x goes to infinity, the 1 obviously is not affected, but these guys all go to 0. So notice I'm going to get 0 over 1, which is 0. Okay, so I've got a horizontal asymptote, okay, at y equals 0. Okay, so that takes care of the horizontal asymptote. Okay, so now I want to look at vertical asymptotes, which means that I've got to look at the numerator and denominator both in factored form. So let's see what happens here. I'll deal with the numerator first. Okay, so notice you have a GCF, okay, of 3. So I factor that guy out, and I have x squared minus 3x, I'm sorry, plus 3x minus 10. Okay, so that factors. Okay, so I've got x plus 5 and x minus 2. Okay. Well, I've got to take a look at that denominator, and I'm thinking, okay, what could I possibly have a factor of x plus 5 or x minus 2 in there? And I could have either one, because 5 and 2 are both factors of 100. I'm going to try x plus 5 first. Okay, you could do long division or synthetic division. Okay, so let's see what's going on. All right, the root of x plus 5 equals 0 is negative 5. Okay, so I'm going to do synthetic division. Okay, and so I have a 1, a 4, a negative 25, and a negative 100, and see whether or not this guy works. So bring the 1 down. Negative 5 times 1 is negative 5. I add and I get negative 1. Negative 5 times negative 1 is positive 5. I add and I get negative 20. Okay, negative 5 times negative 20 is positive 100. Okay, which means I have a remainder of 0. So this guy right here, okay, gives me x squared minus x minus 20 right there. Okay, so I do have a factor of x plus 5. Okay, and then this guy factors into x minus 5 times x plus 4. Okay, x minus 5 times x plus 4. Okay, so let's see. Okay, notice that the x plus 5s cancel off. Okay, so I don't have vertical asymptotes there. Okay, I do have vertical asymptotes, okay, at x equals 5 and x equals negative 4. Okay, so x equals 5 and x equals negative 4. Okay, so I've got my vertical asymptotes. Okay, so notice I don't have a vertical asymptote at x equals negative 5. I have a hole. Okay, so I do have a hole. Okay, and that happens when x is equal to negative 5. Okay, so you say, okay, well, what would be the y value of that hole? Well, once these are canceled off, okay, and we work with reduced forms, I have 3 times x minus 2 and x minus 5 times x plus 4. So if we just evaluate when x equals negative 5 here, okay, and evaluate this guy, okay, so let's see, 3 times negative 5 minus 2 would be negative 7. Okay, and let's see, negative 5 minus 5 is negative 10. And negative 5 plus 4 is negative 1. So it looks like we're getting negative 21 over 10. So that would be my y coordinate. You could leave it that way, or we could write it as negative 2 and 1/10. Either way. Okay, so there's your y value, okay, of the whole. Okay, so negative 2 and 1/10. Okay, right there. Okay, so let's see. I took care of the horizontal asymptotes, I took care of the vertical asymptotes, and I do have a hole, and I identified that. Okay, so we're good there. Okay, let's take a look at this second one. I think this second one's gonna be a little bit easier, I'll be honest with you. Okay, so let's start again with horizontal asymptotes. Okay, so I have to take the limit as x goes to infinity, and clearly the largest degree is 4, so I divide everything by x to the 4th. Okay, so up above I take the x to the 4th, divide by x to the 4th. I take the x squared and divide by x to the 4th. And then I take the negative 20 and divide by x to the 4th. Okay, that takes care of the numerator. Do the same thing to the denominator. Okay, so I take that x to the 4th and divide by x to the 4th. I take that negative 8x squared and divide by x to the 4th. And then I take that 16 and divide by x to the 4th. And then just simplify everything. So we have the limit as x approaches infinity. Okay, let's see, up above in the numerator, I would have a 1 plus 1 over x squared minus, can't do anything with the 20 over x to the 4th. Okay, and down below I have a 1, the minus 8 over x squared, and I can't do anything with the 16 over x to the 4th. Okay, so as x goes to infinity, it doesn't affect the 1, so I get 1. 1 over infinity, that becomes 0. Minus 20 over infinity, that becomes 0. Okay, doesn't do anything to the 1. Okay, 8 over infinity becomes 0. And 16 over infinity becomes 0. So obviously we get 1 over 1, which is just 1. Okay, so I have a horizontal asymptote, okay, at y equals 1. Okay, so we got our horizontal asymptote. Okay, now we want to take a look at vertical asymptotes and holes. All right, now, both of these factor relatively easy because notice that the degree of the middle term is half the degree of the first term in both of them. Okay, so we can easily factor this. Okay, let's see, the numerator, the x to the 4th would split up into x squared and x squared. And then, let's see, factors of negative 20 that add up to 1. That would be a positive 5 and a negative 4. Okay, so we're starting there. Okay, do the same thing down here. Split that up into x squared and x squared, like that. Okay, and so I'm minus and minus. And factors of 16 that add up to 8, that would be 4 and 4. Okay. So notice that I can't do anything with x squared plus 5. I can't factor that anymore. Okay, but I can definitely look at x squared plus 5 and then factor, this is a difference of squares, so x plus 2 and x minus 2. And notice down below, both of them factor that way. So I'd have an x plus 2, an x minus 2, an x plus 2, and an x minus 2, like that. Okay, so notice that the x minus 2 cancels here and here. The x plus 2 cancels here and here, okay? And notice that I still end up with vertical asymptotes, okay? So vertical asymptotes right here, I still end up with a vertical asymptote at x equals negative 2 and x equals positive 2. Okay, so I do get vertical asymptotes. And notice that, you know, we're thinking, well, there's got to be holes there because the x plus 2's and the x minus 2's cancel each other off. But notice we have some multiplicity down here, okay, in the denominator. So although these cancel off, we have additional factors of x plus 2 and x minus 2 to account for vertical asymptotes. Okay, so we do have no holes here. And we're in good shape. Got everything we need. Okay, that takes care of that video.